we're going to find the value of cosine of inverse sine of -4 divided by 5. So when you approach this problem, you always want to start with this inner function. And that, in this case, we have inverse here. So we're going to write this as, let's use theta instead of y. Let's let theta equal inverse sine of -4 divided by 5. That means I can write this as sine of theta equals -4 divided by 5. That means this is your y divided by your r. All right, and also our angle theta has to be in between -pi divided by 2 when we have the inverse and pi divided by 2. That means quadrant 1 and quadrant 4 is our choice. Sine is negative in quadrant 4. That means we're in quadrant 4. So if I draw a picture of this, quadrant 4, my y is -4. And my radius is 5. So I'm just going to estimate here. So this is -4. And our radius here is 5. So what I have to do is find my x here. What is my x? Or you can put the x there if you want. And to do that, you use the Pythagorean theorem or your Pythagorean identities. You can just use your Pythagorean theorem and use x squared plus y squared equals r squared. So we have x squared plus -4 squared equals 5 squared. Therefore, we have x squared equals 25 minus 16. So x squared equals plus or minus, not plus or minus, it's just 9 right now. And when you square root both sides, you're going to get x equals plus or minus 3. All right, since we're in quadrant 4, my x is positive and my y is negative. So I'm just going to take positive. So x is just going to be positive 3. Now we're looking at this whole picture, and this is going to equal x divided by r. So your x is 3 and your r is 5. A faster way to do this problem is when you see your r is 5, this is a Pythagorean triple of 3, 4, 5. So basically we could have skipped all this step if you know your Pythagorean triples here. You just got to be careful with the quadrants. Thank you. Have a nice day. Bye-bye.